and start it over.
All you had to do. Is that right?
I didn't know that.
Netstat, what's it do? We did this in class last time. What's a netstat command do from the command prompt? Seth?
Shows all active connections.
Shows active connections. Anybody try this at home or on home? Yeah, figured that. Okay. Don't pan. Oh, good Lord. Did you just do netstat on your own? Netstat space -an, and those are all the connections to your computer? Wow. I'd say that you have all of China connected to yours right now, trying to steal nuclear codes.
Those Chinese.
That's my guess. Okay, again, it's gonna list every connection by protocol on the computer so you can get an idea. So there are certain ports and protocols that you need to worry about, certain ports and protocols. Again, you're probably not going to use this until you most likely until you start dealing with servers, because then you want to see, okay, if I've got this server, is it configured properly to be listening on port 25 if it's an email server, or if it's a web server, am I listening properly on port 80 or some alternate port to see if it's listening for web requests or HTML traffic. So most likely you won't use this except on a server, but it's kind of nice to know, here are the things that I'm connected to and here are the ports that I'm using to connect to them. And again, just because it shows the port and the protocol up there doesn't mean that there's actually a connection. Up here, which one of these which one of these would you say is an actual live connection? Yes, Austin? The ones that say established, okay? So if you're a server, those are ones that people are connected to you, or it could be you're connected to another machine. Yes, sir?
Well, does this say listening? Are those receiving?
Listening, question was, those that say listening, what does that mean? What it means is those are ports that are opening, or are open on your computer that are waiting for somebody to connect. So it might be a lot of different things. It could be, if this is a server, it might be, you might see one in there, TCP, here's the IP address, port 80:80. Hey, by the way, how do you specify, if I connect to a server and I want to connect using an alternate port, so let's say I've got an IP address of 192.168.1.1, and I want to connect to that server using port 81 instead of port 80, which is the default for a web server. How would I designate that? How would I identify that? Okay, so the example is I've got a web server out there and I know that it's not listening on the default port of port 80. So how would I connect to that server to access the web server? Yes? Where would I put that? You're right. In the URL. So I would type www.hostname.com:81. Why do I not need to put a colon in when I go to other web servers like Google? Why don't I have to put that colon and the port number in it? Yes? It automatically, the default protocols or the default ports are automatically assumed that you're going to connect to the default ports. If I'm using a URL out of a web browser, then it's assuming I'm going to use what port? Port 80. If I'm trying to connect to an email server, it's going to assume, Jill, that I want to connect on what port? An email server. I just mentioned it. Go back to your charts. You know? No? Jessica? For email, what is it? Okay? Good.
25.
Port 25. Okay? By default, email is port 25. What is FTP? Jessica? 21. Port 21. Okay. Any questions about that? That's a netstat command. Understand. I'm sorry? 22 is used for secure FTP. 23, I don't know. Anybody got 23 on their chart? Yes.
TCP 11.
TCP what?
11.
TCP 11.
23.
What do you got?
Mine says tell them not.
Telnet, port 23 is Telnet. That sounds about right. Port 22 is SSH, actually. Okay, layer 6, moving on up the OSI model, the food chain. All right, so give me an example of an application that would use the presentation layer. Remember we talked about each of the layers typically will have both devices and protocols in them. The presentation layer, what application would be using that would use a protocol found at the presentation layer? Someone had their hand up earlier. Based on the description up there. Yes?
Like a 7-zip?
Like a what?
Like a 7-zip or runner?
7-zip, is that what you said?
Yeah.
Like 7-zip, possibly. Possibly. There's another one that comes to mind immediately when you read that second bullet. Yes, Aaron? Encryption, but what kind of applications uses encryption? So what would I be using encryption for? Yes?
Packets?
What's that?
Packets?
Packets, yes, yes. A VPN, a virtual private network, right, a VPN. Let me give you an example of a VPN. I have a client that has an office in Costa Rica. Over the weekend, I spent quite a bit of time, several hours, working on hooking up a domain controller. Who knows what a domain controller is? Caitlin, what's a domain controller? The what? You put your hand in front of your
Yeah,
mouth.
no, I don't know how to explain it, like the thing,
You're right.
I don't know.
Aaron, Q, domain controller.
Like authentication?
Does authentication, yes. It does DNS typically. Okay, domain controller is a server that runs a role, a Windows server, or it could be a Windows server. It is a Windows server. That runs a role that does authentication for the network. So if all of these computers were a member of a domain, they would all connect to a domain controller when they log in the morning. Okay, so verify that you belong to this network and you can have access to all the network services. Okay, so over the weekend, I was setting up a domain controller in the cloud in Microsoft Azure. Anybody heard of Microsoft Azure? No? Yes? No? Okay, Microsoft Azure is Microsoft's service, cloud service, that allows you to put virtual servers in their cloud in place of servers on site at a client. Relatively new offering from Microsoft. They've been doing something similar. We've had private clouds, which I've used on a regular basis. But right now, Microsoft will do, basically we build a server online, put it in the cloud, and then the way the users get to that server is through a VPN. So in the case of what I was doing over the weekend, I was setting up a VPN connection as a test from their corporate office, which is actually in Plymouth, to Microsoft Azure. I established that VPN connection, so I was using presentation layer to establish the VPN connection, layer 6. And that VPN connection means what? What's that VPN connection do for me? I mean, I connect to the internet all day long. We all do. What's different between a VPN connection to the internet and what we do on the internet? Someone other than the Austins. Yes?
It protects you from people trying to come in.
Remember that it protects you from people trying to intercept those packets. Remember that packet sniffer thing we were looking at? We looked at every packet coming across. Well, if I can see every packet coming across, then theoretically I can intercept, grab that packet, strip it apart, and see the data that's being sent. Now, what kind of data is being sent in packets? Give me one example.
Credit card numbers.
Could it be credit card numbers? Or, even better for a hacker,
Social Security.
even better for a hacker, if that hacker is able to intercept the username and password in that initial connection to, remember I told you domain controllers do authentication. If a hacker is able to intercept the username and password, now that hacker has keys to everything. And it knows where it's coming from and it knows where it's going. So the hacker intercepts those packets, strips the packet apart, sees the username of CFeast in my case, and my password, then that hacker is now able to go back to the source server and the destination server and log into both of them and probably get access to a lot more than just credit cards or just social security numbers. It's going to get access to everything. So it's critical that anytime you have a resource like a domain controller out on the internet, in this case at Microsoft Azure, that between the two connections everything is encrypted. And so when you encrypt something, you put it up, you know, you're packaging that packet, that regular packet that you can normally see with a packet sniffer, which I showed you earlier. You're packaging that packet into something that can't be hacked, that can't be stripped apart if it's pulled out of its environment. So it does this through different layers of encryption. You can have 64-bit encryption, you could have 128-bit encryption, you could have 256-bit encryption, and the higher, the more difficult it is to decrypt. Yes, sir? Okay? The higher the encryption, the more bits used in the encryption, the more difficult it is to access that information. Okay? All right, so I was using the presentation layer when I established this VPN connection. In addition to that, the presentation layer is also the first from the application that allows me to get to a resource. How many know what a map drive is? Can someone describe what a map drive is? Can someone describe to me how you get to a resource on the, I'll tell you what, let me give you an example. Let me see if I can do this. Actually, I can't do that with this computer. I'm sorry. I'll have to, yeah, I'll have to do that later. Yes?
Is it like clouds?
Okay, so if I open up Windows Explorer, not quite, if I open up Windows Explorer, not Internet Explorer, and they now call it File Explorer. If I go down here to Network, normally, not on this network because I haven't turned on network discovery. Let's turn it on.
We can't see it.
Oh, sorry. Let me duplicate. Okay, so if I open up File Explorer and I open up Network and I turn on Network Discovery, normally what you'll see in a corporate environment is you'll see not only your own computer or in your home environment if it's designated as a home network in your zones on your operating system, I'll see lots of different computers here because they're all communicating on this network. Okay, the presentation layer allows me to see those computers out there and allows me to connect to them. So if I've got servers out there on the network, you know, if I go to one of my networks, one of my office networks that I work with, I'll see 50 computers out there. Some of them are servers, some of them are workstations, laptops, some of them are phones for that matter. Okay? And what I'll do is I'll double click on them and it'll give me the shares that are available. So those shares, I've consciously advertised them. It's like going to, everybody open up Windows Explorer real quick, or File Explorer, I'm sorry, that's what it's called. Everybody open up File Explorer. And what you should see is something along these lines. Now if you look on the lower left-hand side, or on the left-hand side you see OSC. Okay, that's your hard drive. That's your local hard drive. You may have multiple hard drives on it, you may just have one. If I go to the C drive, I've got these folders. Now this is the root drive. So what I'm going to do is I'm going to share this folder. I'm going to create a new folder. And I'm going to call it data. This is where, if I want Jill to be able to get to my spreadsheets, my Word documents, whatever, I'm going to create this data folder on my computer. I'm going to right click on it, and I'm going to share it. Okay? What that means is I'm going to make it available to other people on the network that I designate as having access to it. I don't necessarily have to call it data. I could call it stuff, and then I give it certain permissions. By default, people can only read it, which is fine. Okay? So now I have this folder out there shared, because I shared it. And so when people go to network, assuming that I'm on the network, and, oh, sorry, wrong drive. They will see my computer in a corporate network environment. They'll see my computer, they'll double click on it, and what will show up is a folder called stuff. They double click on that and they'll see all my internet or all my Word documents, my Excel documents, whatever. So in a corporate environment, I've got all these shares out there. The presentation layer is what allows me to advertise these. It's what allows me to let other computers see my stuff on the network. Now this is a pretty key part of any network. Okay, it's a very, very important part of any network, because one of the big advantages of a network to begin with is the ability to share resources, share printers, share drives, share media files, share all of these different devices. Okay, that's one of the major reasons we have networks to begin with. And so the presentation layer is critical to make that happen. All right, moving up to the last layer, which is the application layer. Okay, the application layer uses specific protocols like FTP, which stands for what, Zach? FTP?
File transfer something?
File Transfer Protocol. SMTP, anybody know that one? Yes?
Isn't it a simple mail transfer?
Simple Mail Transfer Protocol. HTTP, Quentin? Hypertext, just like the other two we just mentioned. Hypertext Transfer Protocol, okay? So it uses those protocols, Telnet, Remote Access Services, which is what RAS is. The layer is not the application itself, but the protocols that are initiated by this layer. So as an example, if I have Microsoft Outlook on my computer, when I open up Outlook, it launches. When I send an email or receive an email, it launches the SMTP protocol normally. Could be a different mail protocol, but normally it's SMTP. When I open up Ipswitch, FTP client, it opens up the FTP protocol when I try to transfer files. When I open up Internet Explorer or Chrome, it launches, and go to a website, it launches the HTTP protocol, or HTTPS, or something along those lines. You could even use Internet Explorer as an FTP client. So where message creation and packet creation begins. So if I want to send a message from my computer in whatever format, that message could be an FTP message, could be an email message, could be a lot of different things. It's where it all begins. Highest layer of the Osi. All right, similar, this is a picture of a packet. Basically, it's using Network Monitor to intercept a packet. If you look on this particular, I mean, you're not going to be able to see the details, but what you'll see is a lot of different stuff highlighted. What you see below with all that text, the actual information on that packet itself. So each one of those above, those lines up above is a packet. And if you look very closely, and you can see this on your slides, which I've included in your OneNote, each of these packets has a source, a destination, an identified protocol, and then additional info. So if you click on one of those packets, then down below you'll see a bunch of additional information. And at the very bottom you'll see the data that's associated with it, which in this case is encrypted data. Okay, so this is the kind of information that's available through a packet sniffer. Why do we use packet sniffers again, besides trying to capture people's social security numbers? Yes?
Oh, so you can see what's going on in the network.
To see what's going on in the network and to help, yes.
Make sure your packets got where
Make sure they're getting where they're supposed to be going, okay? And make sure, I've used packet sniffers most commonly to see if there's a problem on the network. So if I've got a computer that's just bringing the network down and all my indicators on the network are that, you know, it's 80% utilization or even 50% utilization on a network, then clearly I have an overactive device talking on the network. Well, if I open up a packet sniffer and listen on the network, then pretty soon I'll see just an influx from the source. I'll see the same IP address or the same MAC address show up over and over and over again, thousands of packets. And so then I can look at those packets and see what kind of traffic it is. I can look at the source address and find out the machine that's causing the problem, and then invariably I'll run a malware scan or an antivirus scan on that machine and discover that it's trying to send information, literally, it's trying to send information, phoning home to China, phoning home to Russia, phoning home to Bourbon, Indiana, okay? Because someone has created some malware that's sending information to it, okay? All right, back to the OSI model. As you saw in the little video that we did, and also when we talked the first time, the transmitting computer, which can also be considered the source, the transmitting computer uses all 7 layers of the OSI model to send information. Let's say, as an example, the transmitting computer is trying to access a website on the receiving computer. So as it opens up its browser, it enables HTTP at the application layer. Let's say it is trying to establish an encrypted connection to that. Maybe it's the bank. That receiving computer is at the bank and it's trying, the guys or the person is trying to access their bank information. Well, all that's going to be encrypted. So the presentation layer is going to encrypt that message. The packets are going to be created. We're using the session transport layers to encrypt and to ensure that that connection is reliable, making sure the packets are getting back and forth and are the right number of packets and in the right order. Then we're using the network layer to make sure they get to the right destination by using the IP address and routing protocols all the way along. We're using the data link layer to get it from the computer out to the wire, whatever that wire is, and that data link layer changes simply because we're going from, in some cases, wireless to a copper connection to a fiber connection, and then back on the receiving side, you know, it could be 5 different data link layers there, and then the same with the physical. It could be copper, it could be wireless, could be light if it's using fiber connections. Okay? And then it goes back and forth over and over and over again. Okay. This chart you should have in your notes. It's just these protocols in the middle for each of these layers are not all of them. This is not all encompassing. It's just some good examples to help jog your memory as far as what they are. If you saw, I once saw a chart, and it changes all the time, but it could have filled half that wall with each of the layers, all the associated protocols, all the associated devices with each of those layers. I mean, it's huge. These are just common ones that we use. Okay. This is a good start to get you an idea of how the layers work. Now, the video showed the 4 layers of the TCP model. Anybody know what those are? What are the 4 layers of the TCP model? Yes?
Application, transport, internet, and network access.
At-in, that's what I use to remember it. Application, transport, internet, and what did they say the last one was?
Network access.
Okay, network. Now, you'll see different definitions of the 4 layers of the TCP model, but go with the ones that are in your book, because those are the ones that will be reflected on the test. But if you happen to go out on YouTube and find something else, go with the ones that are in your book. Why do we have the TCP model? All right, let's go to the next slide. Why do we have the TCP model? Anyone know? Why? No one knows? Yes, Austin.
It's a more, I guess it's a more refined look at sort of like the communication between like computers and servers on a network instead of the actual physical stuff. It's more or less like from this point to there to the designated server, I guess.
If we're using, I mean, keep in mind that the 7 layers of the OSI model are not just TCP/IP. Okay, there are others that are out there. NetWare had their own version of communications. We won't ask you test questions on that. But this is the #1 communications network, or the #1 communications sub-network, if you will, that we use. We use TCP/IP. I mean, it's pretty much the only communication that we use now. And so if you want to hone in on how that works, like Austin was saying, then you study the 4 layers of the TCP model. There's other stuff that gets involved. All 7 layers do get involved, but if you just want to concentrate on how the message gets from one point to the other, in 90% of the cases, 99% of the communications that takes place on the network, especially on the internet, then you're going to want to follow this and hone in on this. Summary. Going back to the beginning of the lesson. To understand the OSI model, you must define each of the layers from a theory perspective, but then also understand in an actual communication or an actual transmission using some sort of hands-on technique. The hands-on that we used NetStat to see what kinds of connections were connected. We did a ping test to see how IP addresses are come into play, how MAC addresses come into play. We can use a packet sniffer. I showed you a screenshot of a couple different packet sniffers to see how packets are identified and the kinds of information that's available to you. But in order to be able to understand that, the entire OSI model, you really have to have an idea of protocols and devices and then see them in play. I really, truly recommend, if you guys, and I can't remember if Windows 8.1, I doubt it, includes Network Monitor. I don't remember if it does or not. If you want to install Network Monitor, I believe it's a feature, look it up. You're welcome to do that. I told you not to install. Do not install other packet sniffers, but Microsoft's Network Monitor, you can install that as an additional feature or a download if you want to look at, capture some packets and see what's out there. You'll stand a better chance of being able to see a lot of varied traffic with Network Monitor if you are connecting to a wireless network than if you use the wired, because these days in a wired network it's going to be kind of isolated to just unicast traffic, just broadcast traffic, and then the unicast traffic to your workstation. You won't get a real, but in a wireless network it's like the Wild West out there. Okay, you see all kinds of traffic out there, not just traffic that's destined to your machine. So we separate the function of the lower levels of the OSI model, and we call that the communication subnetwork. Memorize which layers of the communication subnetwork. Also, remember that the devices that, the wired devices that we use primarily are switches. That's a continuation of Chapter 1. And those switches primarily work at what level? At what layer of the OSI model? Switches normally work at what layer? Layer 2, which is called the what layer? What's layer 2?
Layer 2.
Yes.
I just have oh, hang on, I got you. Data link layer.
Data link layer, okay. However, switches can also function at the network layer, which means what? What can they do? What can they do? Christopher, what can they do? Or I'm sorry, Johnny, what can they do? Someone, anyone. Jordan, what can they do? Johnny, do you have an answer? They can exchange the information when I'm looking for something specific. Frank. Layer 3 switch can, one word. The puppet master. You managed to. Yes, route. The answer is route. Layer 3 switch can route. Okay? You also need to understand what the TCP model is, which is just a sub section of the overall OSI model. Do you have questions about this chapter? Yes, Austin?
What about the chapter? What are all those orange things in the box?
No clue. Any other questions? Nurse stuff. Okay, go ahead and turn that off. Oh, wait, hold on. Just a reminder, if you miss a class or if you are a remote student, go over the lectures for the day that you missed. So we had probably an hour and a half of lectures last Thursday. That material that's in the lecture will not be found in the book. Material in the lecture that's not found in the book will be found on the test. So make sure you go over those lectures. They're listed in your OneNote. I looked at the first part of the Lesson 2 lecture, and I had 8 or 9 views on that. Okay? I've got, I don't know, 17 or 18 remote students, which tells me at least 9 of those students or 8 of those students are going to fail miserably on the test because all they've done is read the book. I look at part 7 of Lesson 2 lecture, and I've got 3 views, which I understand. It also tells me I'm incredibly boring in these lectures. The problem is that those students who have not watched those lectures or have missed that day in class will not do well on the test. Okay? Go ahead and shut it down.